Right. Hello, everybody. Welcome to our talk today, Views, Compose Multiplatform, oh my. Now, I'll start by explaining a little bit why we're here. So, we've had a long project converting our views-based app to Compose and Compose Multiplatform. While going through this, we found that most of the online resources, most of the stuff you find, covers the ideal. Clean code bases, simple projects, lovely code, but real code isn't all roses and happiness, is it, Greg?
Well, roses are full of thorns and creepy crawlies, so maybe.
True. It might not have exactly been misery, but mixing Views, Compose, and Multiplatform wasn't exactly pain-free. We thought it'd be great to share our experiences for anybody else who might be looking to do the same. In this talk today, we'll start off with the intro. I'll give a bit of context about us and our motivations. Then I'll go through our migration to Jetpack Compose. I'll pick out some of the pain points and some of the things that had really worked for us. Then Greg will take you through what we found when we added in Compose Multiplatform and our experiences working there. And then finally we'll have a recap and a quick conclusion over how the project went. With that, I'll carry on with the intro. So, I'm Jimmy Ray, been making Android apps for about 15 years now, makes me feel dead old. I organise GDG in Android Manchester, so if any of you are up north, please come along. We've got some great sessions going on there. And a long time ago, I had a job testing PlayStation games and actually got paid for it, and I don't know why it changed.
So, hello, I'm Greg. I've been developing Android for 6 years, and this is my first ever droidcon talk, so if I make some mistakes, please give me some rope. And my fun fact is that I make the finest spaghetti bolognese with pineapple in the whole of Manchester.
It's probably because it's the only spaghetti bolognese with pineapple, mate.
Yeah, but it's still the finest.
We're presenting this talk, but this is very much a team effort. At Autotrader, we've got 13 Android app developers, including ourselves. And then we've got more iOS and QA as well, so props to everybody who's worked on this for us. Speaking of Autotrader, that's who we work for. We're a magazine way back when. Now we're a technology company. We're the UK's biggest automotive marketplace. We stopped the magazines a while back. We get about over 18 million searches a day. We get a lot of traffic. That's no car pun intended. Most cars in the UK sold in the UK go through Autotrader. And our apps cater for the majority of those users. Thousands of businesses rely on us to sell their vehicles. Millions of users rely on us to buy stuff. And we take pride in making that the best experience. Now, it's an old experience. Our code base has got commits going back to about 2011 when I looked at the history. There's a lot of code in there. We're always evolving, we're always changing. There's old code and there's new code working together. And about 5 years ago, we started building our server-driven UI framework. If you see SDUI anywhere, that means server-driven UI. If you want to know more about that, we did do a talk last year, so that QR code should take you to the talk. But the key point is we build up dynamic UI based on what's sent from the server, so when we're converting to Jetpack Compose, it makes the problems and nuances a lot more complicated and a lot more interesting. When we started this, Jetpack was only alpha as well, so we built it all using views. Don't really think, does anybody really want to go through why Jetpack's better? Anybody think that Jetpack's worse than Views? No, there was a few reasons why we wanted to move. Our views were full of bugs and little quirks that we'd fixed along the way. It was getting harder to change, it was getting harder to update things. People wanted the nice animations in Jetpack and the team wanted to work on the latest tech. So, as you can probably guess, we started migrating to Compose. It'd be a rubbish talk if we didn't. So we didn't have the QA time or QA power to go and rewrite the whole thing from scratch. So where do you start? Thankfully, there's a lot of information available online. The Android developer docs are absolutely brilliant. You can start by replacing UI at a widget or a screen level. So you can use Compose views to put in Jetpack content into the original Android layout. Or you can do Android views in Compose, but we don't do that as much. Our module structure was already set up in a pretty good place. We had a design package which handed out widgets to the other modules in the app. This meant that if we replaced at a widget level with a Compose view, the rest of the app would then be rendering Jetpack Compose, even though it was still an old view-based screen. The client UI modules themselves, we could replace them with Jetpack Compose as we went along. If there was a new feature that we needed or we needed to work on an old screen, we could just replace that entirely. But the interesting bit was the server-driven UI, because this is kind of a complex library that builds up things dynamically. We can't just big bang change it and chuck it out, or it's going to take us ages, and then we're going to realize we've broken half of it. Tried that many a times in the past. So, server sends down a bunch of JSON, the app reads it, and builds that into a set of component objects. Each component object has a function that can render a view. You probably recognize this a bit. It's the same way Jetpack Compose really works. You call one top-level composable, it renders all the children and all the things to return a single view. Voila. So we wanted to move that framework into Jetpack, but without doing a big bang release. We knew we could use Compose views. So the first thing is pretty simple. We do one component at a time. And then we could use mobbing sessions, 10% time, everybody get involved. We wanted to share the learnings, so the mobbing was really, really good. Instead of just doing it in a project on its own and have one person just kind of change things across. And converting like this, rather than the big bang, was great for the most part. We didn't hit any noticeable performance issues. In fact, the performance went up a little bit in a few areas. We could feature toggle and A/B test the changes, and we could release and test quickly. So if we released a new version of a button, say, and we found out that something wasn't quite working with it, we knew it was the button because that's the only release we'd done. We hadn't released a pile of things at once. However, it wasn't exactly pain-free. And I'm not talking about the layout components like the column and the row there. I'll come back to them later. One of the first big interop issues that we hit was focus. And by focus, I'm talking about what happens when you enter text in a text box and you hit the enter key or you press down and you want to go to the next widget on the screen. Now, our issue here was compounded as well because we didn't know where these things were going to get laid out. We're just kind of like drawing them on the screen based on what's sent from the server. And when you get a mix of Compose and views, it starts getting a bit funky. So when you're only using the view-based system, the UI can detect what's going to be focusable next, and then it can go on to that next element, and eventually finish off when you've got the close button. When you've got Compose in Android views, the system can only actually see a list of Compose views. And within Jetpack land, it doesn't know what the next focusable element is at all anyway, because there's no other focables in that Jetpack view. So it tries and gets nowhere. Now, our fix for this, if you ever hit this and you need to work around it ourselves, ended up in two parts. For the first part, within Jetpack, you've got, well, within the ViewLAN, you've got the focus finder. So this is part of the Android view package, and it'll tell Android to look for the next focus within a layout. So this got us focusing the next view. If anybody's worked with this before, you'll know there are some exceptions you've got to catch in that block, but it doesn't work well on a slide, so I deleted those things. Once you've got the views working out what to focus correctly, we've got the focus requester. So in Jetpack land, if you want to request focus, you use a focus requester. And we can actually keep a reference to that in the Android view land. So when the Android view gets focus, we call back into the Compose view and tell it to request its focus. There's probably obviously really nice ways to handle this. If you know exactly where your UI tree is going to be going, you can use this inside the UI and you don't have to pass it around the way we've been doing. But because we're building things up dynamically, it's just a completely different paradigm to what you'd have on a normal screen. Another thing we hit was scrolling. Now, scrolling is a pain in the backside, whatever you work with. I'm sure people have had fun with nested scroll layouts and stuff before, but it gets more complex when you're managing multiple UI systems. One of the main ones we had was with map views. So when testing, the maps initially worked fine. You could scroll with one finger, you could move around, but when we checked on a device, pinch zoom wasn't working. It was really choppy and unusable and laggy. And we found out that that was because the view hierarchy was not grabbing the first touch, but it was messing around with the second one. So there's probably some great clean solutions for this, like not putting maps in nested scroll layouts anyway. But that really, we really didn't have a choice about that because we were letting other developers build up the UI for us based on our system. So in our case, we needed a generic solution which would stop those touch events happening. And here, we could wrap our Compose views inside a frame layout. When the touch events happen, we ask the parent to stop interacting. Frustratingly, Compose view at the time, I think it still is as a seal, it wasn't open, so you can't extend Compose view and do this functionality on it. You've got to add that in on top of it. Now, sadly, I don't have time to go through loads and loads of stuff. I wanted to keep the Jetpack stuff a little bit light and do a mix of multi-platform as well. So I'll jump back onto the conversion journey. We hit a point where a good chunk of our UI was in Jetpack. About 60–70% of the UI was in Jetpack. But we still had our main bits, and our layouts and stuff we use in views, and land of interop was becoming a bit of a burden, really. All of the components that we'd convert in were still relying on the view system for the layout handling, so if we wanted to do width or anything, that was still relying on layout params. And we were getting a lot of issues and hacky workarounds like I've just shown creeping in, and we wanted to move away from that, really. And we're still not converted those things, and that was going to be a pain. We didn't want to live in a world where we've got Compose views, inside of Compose, inside of views, and outside of Compose, and it'd just be a nightmare. So it was time to move to full Compose, and I figured out that any project like this, you're going to have one point where you've just got to stop incrementally changing things over and just face it. You've got to do a big bang project and convert all your layouts at once. So this could be a screen, or in our case, it was the rest of our library. So we got a team together and worked on it as a dedicated project. Now, our views were made via a factory, and thankfully it made it pretty easy that we could feature toggle between the two. So we made a Compose version of the factory that spat out Compose views, and we left the original view factory still in the app so we could convert and keep comparing. Anything that wasn't ready went into an Android view, and if there was stuff that we could convert reasonably quickly, we'd just put a placeholder in Compose land. So even though our users were seeing the original layout and everything was working fine, we had this other system under the hood that nobody knew about unless you were a developer and you could find the fancy button. It does bring us on to layouts though, because this was the final bit of the Jetpack Compose conversion. There's some really interesting stuff that we found out with this. So we make up screens using a lot of nested components. We don't know how they're laid out in our framework. But they've got to match exactly how they worked before. So they're using views, but our Jetpack Compose stuff has to match exactly what it did. We can't get away with changing any functionality or changing any requirements there. And each time we change one of the behaviors of how we laid out the widths of our items, something else would break. It was like a game of whack-a-mole. Or just like, we'd get one screen working, look at another screen, and everything was shot off the screen, and it was just a nightmare. So I'll show you a couple of examples of this. A little bit of context. Our UI components had some width options. You could have a fixed width, a percentage width, which should be a percentage of the container it was in, wrap content, fill space, or default, which was often fill, but thankfully, we didn't actually realize about it at the time, and it could have been anything, so all the components acted in different ways, and we didn't really know if nobody specified anything. Some conversions were fairly simple, so we've got something that will fill space, and then a box on the right that's got a fixed width. It's just modify weight and width. Whilst it was in a linear layout, we would have set the view width to 0 and given it a weight of 1. Very straightforward to convert to. But not everything was so easy to convert. So here we wanted two things that filled up 30% of the screen, and then a box that filled the rest of the space and pushed those two layouts out. You'd assume, who here thinks this is the right way to do it? You've got fill max width, and it can take in a float, which will be a percentage of the layout. Oh. Well, right, now it doesn't. I thought that would work, and I was really happy with that until we found one of the layouts had two things in it. And it turns out that the way this works in Compose is the first width takes 30% of the layout, spot on. Anything else takes 30% of the space left after the first one took its 30%. So you end up with smaller and smaller and smaller boxes until there's nothing left. It's bonkers. So to actually achieve this, we had to work out the width of the Compose view that was in the thing was laid out in, and then use a third of that, and then use required width, because if you use the normal width modifier, it won't give you, it's only a preferred width. It's not the exact width, so it'll push some of the space out. That was a fun one anyway. Let's go a little bit quicker now. So another example here, the text was wrap content. We've got fill space in 250. You think wrap content width works? This actually does work fine. But then we found out that somebody had actually done that layout and they'd put the text inside a column. So the text was defaulted to fill space, but the parent was wrap content. When that actually went on screen, it ended up something like that. Now, this is where we had to start looking at intrinsics, and that was actually a really good solution for this. With intrinsic modifiers, using the intrinsic max, it'll work out the maximum space that the text's going to take, and it'll only fill that. If you want to do min, does it over 2 lines, which wasn't the desired effect. I think we tried min first and then thought intrinsics as a whole didn't work until we tried max. Went, oh, yeah, it was just that. So yeah, it was a nightmare. We had to do this generically for all the layouts. So we couldn't just fix one thing. We couldn't just go, oh, text has to use intrinsic size. We had to say, oh, you're going to use intrinsic size for everything, which took absolutely ages. It took, I think we estimated about 6 weeks to finish the rest of the project. It was 3 months. But yeah, once we got it over, we're in a much better place. One of the key saviors was snapshot tests. So we made snapshots of a pile of the layouts. And every time we just modified the widths and how everything worked until all of the layouts worked. I can't explain enough how much those snapshots actually helped. If it was just pure screens, it would have been a lot easier. So while it was working, and moving to pure Jetpack made life a lot easier. We ended up with a few components that were still Android views, and now most of the stack was actually fully Jetpack composed by the end of it, bar the few Android views. But it wasn't fully Jetpack compose. And And I'll hand over to Greg for that one now.
Thank you, Jimmy. So yeah, during our Jetpack Compose migration, we decided we wanted to look at Compose Multiplatform because it was growing both in popularity and in functionality, but most importantly, stability. And we saw that it had great potential for us. Like we could possibly have a desktop app to preview the SD UI, or we could maybe use WASM produce UI for the web. And given we've migrated a lot of our UI to Compose anyway, we thought it would be a free win. And so midway through the migration, we thought, okay, we're moving to Compose Multiplatform. But it wasn't entirely straightforward. And so there's a few things I want to talk about for the next 15 minutes. So firstly, how do you get started? What kind of repository structure do you use? Bear in mind, our apps are over a decade old. Second, I want to think about what we need to bear in mind when transitioning from a single target application to a multi-target application. I want to describe some of the tooling issues that we encountered along the way, namely previews. I want to discuss our approach to testing. And finally, I'll have a few words to say about our iOS integration. So on to the first point, we're going to use CMP. How do you get started? Our native apps are pretty old, and there's a lot going on behind the scenes beyond just the code itself. Do we just stop the world and slap it all into a single repository? Is that something that we could do, even if we wanted to? And if we could, how do you get iOS and Android teams both on board with that idea? Maybe you have it as a standalone repository and publish CMP as an executable. But this deviates from the standard documentation and examples, so what obstacles might we encounter along the way, especially around tooling? Maybe we wanted a single repository, but we could have tried linking in the other apps with Git submodules. I've worked with Git submodules, and they're great at times, but if you make a mistake, they can be absolutely horrible. Did we want to impose that on the team? And again, how do you sell this idea? Or maybe just give up and try something easy because it's too hard. We didn't know the answer to these questions, and I imagine some of you don't know the answer either. But maybe AI has the answer. So you might say to ChatGPT that your native apps are a little bit old, and you need to somehow integrate Compose Multiplatform, and you want to know what is a sensible way to get started. That's actually what I asked ChatGPT, and it came back with this. Now, for some of you in the audience with a skeptical streak, maybe this is not the answer that we're looking for. And to be honest, for us at least, I don't think anybody did have the answer. So with that, I'm going to briefly talk about the journey that we took and some of the problems we encountered along the way. So firstly, we published KMP already from another repository to provide schema for our SDUI. And so we thought we'd play the same game as CMP, which is Compose Multiplatform, and publish an executable for iOS and Android. There's a number of problems with this, but one that I want to talk about is build time latency. Usually, a developer pushes the code to CI, and if it's green, they're ready to merge. However, now we have to wait for two pipelines to go green at the same time, and sometimes it fail through no fault of the developer, so there's a lot of contention in CI. And we wound up with developers working later in the evening or earlier in the morning just so they could merge the stuff, which isn't good. But the thing is, at this point in time, we weren't actually targeting, we were targeting iOS, sorry, but we weren't actually doing anything with it. It was doing its own thing. But to be honest, we figured that iOS wasn't a now problem and that we could perhaps embed CMP inside Android, and this would reduce the CI complexity. Also, in order to build the JVM, we'd need to decouple the UI from Android, so when we do get around to iOS later, it will be easier. However, at some point, we did reach the point where we needed to worry about iOS, and obviously the current structure does not work. We'd assumed up to here that decoupling would have made it easy, but unfortunately it was not. As I mentioned earlier, we already have a KMP library that iOS consumes, and this library publishes an XE framework. We tried to house our new CMP side by side with KMP, but there's a small problem here. You see, we already publish a single XE framework, and it turns out it's a bad idea if you publish two or more of them. You wind up with two Kotlin runtimes, and the classes and functions inside one of them can't see the other. And also, when we did it, we found that symbols got mangled, presumably because of name clashes in the frameworks. So we did a little bit of restructuring, and this is the picture that we wound up with. We've got an umbrella module that publishes a single XE framework for iOS, and inside these are the KMP and CMP modules that we publish for Android. We're currently working on this at the moment, and I'll have more to say on our iOS integration a little bit later. So moving on, an Android app is one-dimensional. Sure, it's got different modules, but at the end of it all, you've just got a single target, Android. In Kotlin, Compose Multiplatform, however, it's multidimensional. You can build in Android, iOS, desktop, or the web. Moving your UI out of Android and into CMP forces you to think about this much larger universe of applications. And you may well find yourself having to battle with things that are unfamiliar, which may well be natural on these different platforms. So here's one of many ways that a CMP might be structured. Depending on what you're writing and for what platform, you might put your logic in any one of these modules. But one of those I want to look at in more detail is common main, because in this module, any code you put here must compile on all platforms. And that means that all libraries need to be available on every platform that you're targeting. So how is this a problem? Well, suppose you've got some UI in Android. Behind the scenes, you'll be relying on functionality that comes from various libraries. Can we just copy all that UI, paste it into common main, and call it a day? In some cases, you can, because the libraries you're using have a definition in the targets that you're supporting. And if that's the case, congratulations, do your slow motion walk to victory. However, sometimes it isn't. In those cases, you'll wind up in this situation, where there's one library or several, depending on it, doesn't actually exist on some target. Or if it does exist, it's missing something. If that happens, what now? Well, this is where you have to start using actual expect logic. You'll call your expect function in common main, and then this gets resolved to the actual implementation for the platform. But the problem is, you have to define this behavior on non-Android targets, and that's not always straightforward. A simple example of this was with some of our APIs that take color in both the new and legacy code. Color representation on Android and iOS is quite simple, regarded as an int. But for iOS, it's a little bit trickier. So we defined a platform color interface, which type aliases to int on JVM and Android, and the UI color on iOS. We then wanted to define an extension function, which will return a Jetpack Compose color. This was easy in Android and JVM, because you just pass the platform color, which is an int, to the constructor. But in iOS, it's a little bit more fiddly. They don't expose a function to get the integer value, so we had to work with Kotlin bindings to Objective-C that would allow us to populate the individual color components and then pass these to the RGBA color constructor. Also in Java, you really need to think about pointers or memory. But in C-like languages, you have to allocate and deallocate memory yourself, and that's what this memscope block is doing. When the function is finished, it releases any memory that's been allocated. If you don't do this, you'll wind up with a memory leak. And these are the kind of things that you have to think of when you're moving out of the safe and familiar JVM world. You might also find yourself writing Objective-C or Swift, actually in iOS itself. I've done this once, and I'm not going to talk about it because I'm still recuperating. And I want to finish off this section with a brief talk about resources. Depending on how you've structured the CMP module or modules, this is either going to be a little bit fiddly or absolutely horrible. But anyway, the general idea is that you'll define your single collection of resources, drawables, fonts, whatever. You place them in the location that Compose plugin expects to find them, namely Compose resources, and they'll be bundled into the final executable. Behind the scenes, the plugin will create accessors for these. And so the fiddly part is to update all your references to r.drawable and then build your project again in order that you can actually see them. This is mentioned in the official docs, but this is how we've actually configured it in our own project. We're applying the plugin, and then we're depending on resources, which we need in order to be able to type in the source code. Additionally, if you've got a parent module that's responsible for producing XC frameworks, you'll need your build file to have the same plugins applied. We're still battling with this one, because we've got a slightly more complicated module structure. After following the documentation and performing the sacred rituals, the Gradle gives us 2 thumbs up and says everything's fine. But then at runtime, the app crashes, because after jumping through all the hoops and going through everything that we meant to do, the images weren't bundled in the first place. Other teams have experienced this issue before. Hopefully this will get better as things get more stable. I'm now going to talk about previews. So, that's not actually a quote that Mr. Jobs said, but I'm sure if he was still with us, he definitely would have said that, because previews are great. And in Android, we're kind of spoiled with just how well they work. You can render loads of them, and they get updated in real time without having to launch the app. You can define them with different configuration options like light or dark. And you can even run that specific preview in an emulator and debug it. But when we first started the migration, we weren't able to see any previews that we defined in common main. In fact, even if we put them in Android main, we couldn't see them. So for that reason, we started by relying on the desktop preview annotation with an IntelliJ plugin. It's a bit clunky to work with, since they only work with IntelliJ. You have to switch out of Android Studio. They don't update in real time, and you couldn't set any configuration options on them. Making the best of this bad situation, however, we did gather up all these functions using Kotlin serial processing and created snapshots for them. We also defined our own annotations in order to specify configuration options. So we didn't get to see them in real time, but we did get notified if we broke something, which isn't too bad. There's some good news, however. With the latest version of Android Studio, Narwhal, I can confirm that there is support. But there's a caveat that you need a dependency on Compose UI tooling, otherwise it bails out with a class not found exception. I've tested this with 1.9.4 and it's all good. And now on to the tests. We do have some instrumentation tests, but most of our UI tests run on JVM via Roboelectric. Whether that's a good thing or not is a topic for another talk. Since we want to be reusing the same UI on multiple targets, we figured it would make sense that these tests apply to all targets, not just Android. And like with production code, we couldn't just slap it all into Android test and call it a day. Also, we use Mockito. This is more for historical reasons since the app's pretty old, and that's what you used back then. It would have been more trouble than it's worth to maintain two libraries. The drawback, though, is it looks and feels a lot different to the framework that we use in Common Test. On that point, there's a number of different options, like Mock KMP or Mockative, but the framework that we use is Mockery. I do actually think it's pretty good, and it looks a lot like Mock K, but it's different in some ways. However, regardless of what library your team decides to go with, there will be limitations of what it can do, simply because all the tests here have to compile and run on all platforms. One example that I found particularly tricky were tests that use spies, which can be very convenient in some cases, but if the class that you want to spy isn't open, then you'll get a build error when running the tests, and this is a known limitation, and it's mentioned in the Mockery documentation. Also, the original tests have been specifically written to probe behaviours on Android. And so sometimes these tests pass on Android, but then completely failed for another target. In some cases, there was an easy fix, but more often than not, there were some details about the platform that the tests just weren't capturing. And this took a lot of time to debug, especially when the tests were poorly written. Finally, and this is almost comical, but if you use backtick notation in your test titles, make sure you don't have commas in them, because if you target iOS, they won't compile. Good old iOS. So, and that segues us finally into the final part of the section, and I should probably come clean, we're still working on iOS. We've had a couple of spikes, and the outcomes for the most part have been quite promising, but we found an interesting discovery. We tried to take the same approach that we did in Android and do it component by component, but we discovered if you try and render a lot of individual views, then the application freezes. The number is somewhere around about 32, and it seems like this is a well-known issue with the metal graphics layer, so we'd have to be rendering entire views all at once. As I mentioned earlier, we've been struggling bundling resources. One thing I strongly advise is that you plan for uncaught exceptions. I've attached a link to a useful article that explains how this is done for iOS view controllers, but it's not nice when a Kotlin exception happens and your app crashes without any form of stat trace. And often the crash will happen in code that you don't own, so you can't even put print statements in there. Finally, we're not using any of the UI yet in the iOS app, so we typically disable it from the build configuration. But the consequence of that is that when a developer comes along to work on it again, the Gradle configuration has all changed, and so you've got a big old battle to fight to get it back to life. And compounding this issue is that most of us Android engineers are not so familiar with iOS. And so once it goes over the wall into Xcode land, any build errors that can be very mysterious and time-consuming to sort out. But all that said, I do think these are teething troubles, and we will get there.
Yeah. So that brings us to the conclusion of the talk. Quick recap over everything. Jetpack Compose, nesting views and incremental conversion did work well for a while, but you're probably going to end up having a big bang project at the end with that. A few things to look out for. Focus caught us off guard. We didn't expect it to be that difficult with it. Nested scrolling and layout params. The layout params aren't exactly one-for-one with what you'd expect on an Android view, and there can be quirks with that. But if you've just got a normal screen, you're probably not going to see the issues that we had. And incremental release was really, really massive lifesaver, and same for the snapshot testing so that we could regress over any changes that we'd had. On the CMP side, it's not a free win. We thought it'd be a free win. There's a lot of stuff that you can just chuck in common main and it works and it's great, but there's also a lot of stuff that you can't. The repository structure, you need to think about that before you do it. Libraries and integrations on iOS, again, another thing to consider. And then one thing that we haven't actually put up there is the Gradle knowledge. It surprised me how much our Gradle knowledge had to go up, because suddenly you had to have people that are real experts in Gradle, and until then it's just kind of like adding a few changes. Once you add KMP, it goes nuts. It's left us in a decent place though. We've got a lot of stuff converted into Jetpack Compose. We've got most of it actually converted into Kotlin, well, Compose Multiplatform, so we're actually ready to have a desktop app. It's just not fully feature complete yet. And there's a couple of bits that are still in Android. Is it worth it? From a Compose point, definitely. We've actually seen some big performance improvements. It's about 100% performance improvement on our advert on Crashlytics, which was really, really good. Compose is great to work with. It's the future of Android. Everybody loves it. Multi-platform. It was a lot of effort, and we've not actually seen the rewards just yet, but we're in a really, really good place to get those rewards now. And just the knowledge that a team's gathered is actually brilliant, so I definitely recommend it if you've got any ideas with it. I'm not sure if Greg would completely agree on everything.
Well, knowing what we know now, I think we could have done things a little bit differently. I think that leaving iOS so late is probably not the best move. The Gradle configuration keeps changing, and it's difficult to play nicely with iOS when it's changed so much from last time. Also, I think jumping around with the repository structure would have been moot point if we'd sorted the iOS side out. We also need to do a little bit of cross-platform leveling up. CMP development doesn't really lend itself to the conveyor belt approach, i.e. you can't just have Android developers doing Android, iOS developers doing iOS, and then put it all together and it all works. That's just not the way it works. Another thing that we really should have thought about was the tests. We've rewritten a lot of tests to put them into common tests, but they were originally Android tests, and now, at best, we've just got a lot of tests written for Android that happen to be passing on all the different platforms, and that's a lot different to testing the different platforms. So we've wasted a lot of time there, and I strongly recommend you guys don't do the same as we did. So, for Compose Multiplatform, was it worth it? To be honest, I would say yes, but more for the learning experience. We're not over the line yet. We often need to stray outside of the simple examples, and there's not a wealth of knowledge to find there. So finding the right solution and knowing why it's the right solution isn't always easy. To put it another way, if I was starting a new project, it's a no-brainer. But for a complex application that's been around for a while, just brace yourself for challenges.
Yeah. That brings us to the end. Thank you everybody for coming. I hope you've learnt something and taken something away from that.